Hi, my name is Gin Sheh. This is for the homework find number 1 question. The question is x and y are independent with the f of x this is the function ux minus u of x minus 1. F of y equal to u of y minus 1 minus u of y minus 2. Z equal to x plus y, so we need to find out what is f of z is. The first one is f of x equal to ux minus 1, and in the geometry this is gonna be look like this one. Ux is here minus ux minus 1, ux minus 1, and then this f of y is uy minus 1 minus uy minus 2, so uy minus 1 and minus uy minus 2, that's here. So we need to convolution these two, and in the geometry it's gonna be like this way. We fix this one, not moving, and we moving f of x, so fx move toward this way. So when the first they just join as a 0, and then f of x start rolling to this way. So when the f of x is in the ux minus 1 and ux minus 2 position, they're gonna be the highest point, which is this one, equal to 1. This at the 2 position here. So when this one move to here, so that's gonna be here. This here gonna be 1, and then f of x continue to move forward, and then the shape gonna be decrease to 0 until the f of x totally out of this position, number 2. So that's for the geometry approach. So now we need to do the convolution approach. So f of z equal to fx of z multiplied fy of z. So we have this one. We treat this one. There's a kind of formula, so we need to drop this one, f of x, the whole thing to here, y the whole thing to here, and dx. So remember we have this condition, the z equal to x plus y, so y equal to z minus x, and then we drop this one to every y. So for the x we don't move anything. For the y equal to z minus x, and then minus 1. Z equal to y equal to z minus x, and then minus 2. So we need to open this we need to open this one. So this u of x multiplied by u of z minus x minus 1, and then minus u of x and u of z minus x minus 2, and then this one, u of x minus 1 multiplied by u of z minus z minus x minus 1. That's going to be this one, and then this one. That's negative, negative, that's positive. So this one become positive. That's u of x minus 1 multiplied by u of z minus x minus 2. That's the whole thing. So we can treat this one, there's a minus. We can treat this whole thing into 4 integral. So that's gonna be the first one, that's gonna be the second, that's gonna be the third, and there's a fourth one. So it will become like this way. So we need to integrate individual. So then we know the z, because of it start from here. We start integral from here. So here we need to from 1 integral to the z minus 1. So that's so we multiply u, the whole thing, this one multiply u of z minus 1. So this, when the box f of x box is moving to the toward to the right, so the next step is z minus 2. That's from 1 to z minus 2. So here we multiply by u of z minus 1. Sorry, here's minus 2. And then third one is this one, because when the box is exactly matched to, exactly the same position as the fy of x, they are totally matched to each other in this position 1 and 2. So in here, that should be, we integral from 2 to minus 2. That's the wrong one, sorry. So here we multiply by z minus 2. And then the last one, when the box fy of x box move out of just right, leave the fy of x. So here's from 2, integral from 2 to z minus 2, and then here's minus 3, because the position of f of x already moved to here. So here is minus 3. So then we need to integrate this one. So this is because here is dx, so here become x, dx, this become 1. So then u of z minus 1 will remain here, because this one is not in the integral. And then we have the second one is this one, because there's a dx, so we have dx here. Then third one we have this one, and then fourth we got this one. So we openly so we need to finish the then we start to integrate this. So z minus 1 is here. Here is 1, so we don't care. Z minus 1 is this one, and uz, and then z minus 2 and uz minus 2, this wrong one, and then z minus 2 and then uz minus uz minus 2, and then this one. So this is my answer. And according to this one, I have a drawing for this. Remember, we have, okay, we have f of x start from here, so we just touch to each other. So we start rolling. This position is z minus 1 u z minus 1, and we start rolling, and also this is u, this position is this one. We're rolling. So when the box f of x is in match to here, so from when the fy of x to 100% cover fy of y, then we have this point, and this is the formula. So at this moment it still go up, so we need to minus another one to make it go down, to make the whole shape, this one, go down. So we have another one that's become flat. Then we start rolling to the right. So this is when it flat. So when we have a flat one, then we have another one, which is when the fx of x out of fy of y. So we need to, this at the moment that's still going down, so we need to plus this one to make the shape go back to 0, this point. Plus it means go up, so make this one. So then we have this. This is my final answer. There's a final drawing which we match to this. Thank you.